Good day everyone, welcome to another video tutorial. Today we're going to revisit the slope of the line. This tutorial is in preparation for the next lesson, which is proving geometric properties in coordinate planes. So let's go with our study and let's recall what is the slope of the line. So as you can see, there are different graphs of line in your screen. So this line 1, this line are line 1, line 2, and line 3. Now how can we differentiate each line? We can say that the three lines differs from their steepness. So this one is line 2 is steeper compared to line 1, while line 3 is not is there's no steepness at all. So to make a comparison of the steepness between lines more efficient, it is necessary to assign a numerical value to it. The term slope is used to refer to the steepness of the line. So that is the slope, the steepness of the line. A slope, or M, of a non-vertical line that passes through point 1 and point 2 is defined to be this by this formula. The slope is equal to the difference in y over the difference in x coordinates. So since the lines is non-vertical, therefore x sub 1 and x sub 2 should not be equal to each other. Because if x sub 1 and x sub 2 is equal to each other, it would give us an undefined answer. Because x sub 2 minus x sub 1 will leads to 0. That will make the slope as an undefined. Now, find the slope of the line that passes through each of the following points. Remember, we're just going to revisit the slope here. So we'll be practicing the use of slope formula. We will not be using line equation and relate it to slope. We'll just use the slope formula, which is m is equal to the change in y all over change in x. Now let's start with the first point, that is 4 comma 2 and negative 1 comma 3. So let's compute, or let's find the slope of the line that passes through this point. So first we will be assigning variables onto it. This will be our point 1 and our point 2. So this is x sub 1, y sub 1, x sub 2, y sub 1, y sub 2. So we will write the slope formula, and the next step is, much easier, is to substitute all our given into our formula. So that's it. So negative 3 minus 2 all over negative 1 minus 4. Now let's simplify the denominator and the numerator, and that would give us negative 3 minus 2 is negative 5, and negative 1 minus 4 is negative 5 as well. And to simplify it further, the slope of the line that passes through these 2 points is 1 is 1. Now for letter B, let's use again the same step. Let's assign points. This will be point 1 and point 2. Now let's write the slope formula, and let's substitute the given that we have. So that is 2 minus negative 2. Remember to put a parenthesis when substituting negative number next to the subtraction sign. All over negative 4 minus 2. Let's simplify the numerator and denominator first. 2 minus negative 2 gives us positive 4, and negative 4 minus 2 gives us negative 6. To simplify it further, we have the slope of negative 2 over 3. Now the third one, letter C. Again, same process. Decide which point is point 1 and point 2. This will be point 1 and point 2. Then after this, we will be substituting all the value, the given that we have to the formula. That is 7 minus 7 and 4 minus negative 9. See how I enclose negative 9? Because subtraction sign preceded by the negative number. It is easier and it will be neat if we put this negative number inside the parenthesis line. Now if there's double negative, this will become positive. This will become 4 plus 9. Okay, now let's simplify it further. Now 0 over 13 is equivalent to 0. This means that this line is a horizontal line. Whenever the slope is equal to 0, that means that this is an horizontal line. Or the graph of it is like this, or like this. We never know because we don't know the equation of the line. We could solve it, but that would not be beneficial for our next lesson, which is the coordinate proof. Now again, let's do this one. Since a while ago I make a disclaimer, or I make a note that x sub 1 and x sub 2 should not be equal to each other. But in this case, it would be easy for us to illustrate why that's not the why is that there should be no values or points that having the same x coordinates. Let me show you how. The reason is if we substitute this one to the x, negative 2 minus negative 2, it will give us a value of 0. And that would give us any number that has a denominator of 0 is an undefined number. The slope is undefined. Or some said that the slope is a vertical line, or the line is a vertical line. Okay, there are special relationship of the line that can be found using the slope. So if the slope of line 1 and line 2 is parallel to each other, then their slope will equal to each other. Again, if line 1 is parallel to line 2, then their slope is equal to each other. Now, if line 1 is perpendicular to line 2, therefore, the slope of line 1 is the negative reciprocal of the slope of line 2. Or if we multiply them to each other, they will yield to negative 1. Okay, let's show this. Let's just imagine that this is a line that passes through this point, and this is line 2 that passes through this point. We will compare the relationship of these two lines. Same as with letter B. This is line 1 and this is line 2. All we need to do is to get the slope of, let's start with A. Let's get the slope of the two lines. Okay, let's start with this line first, containing this point. I substitute negative 1 minus 7 and negative 3 minus 1. And let's simplify it. It will become negative 8 over 4, or the slope is 2. On the other hand, this line 2, let's see their slope. So we have 1 minus 7 and negative 5 minus negative 2. That gives us negative 6 over negative 3. And if we simplify it further, the slope is also 2. Since that slope of line 1 is equivalent to the slope of line 2, therefore the pair of lines are parallel to each other. So that's the relationship of these two lines. For line B, let's do the same as we on the second example. On the B example, let's do the same to both of the lines. Let's identify the point 1 and point 2. In this line, this will be the point 1, this will be the point 2. Point 1, point 2. Now let's use the slope formula. Substitute the values. Minus 9, negative 2 minus 2. Simplify it and simplify it further. So the slope here is 1. On the other hand, we have 6 minus negative 2 and negative 5 minus 3. So that if we simplify that, we have 8 minus minus of all over negative 8. If we simplify that, that is negative 1. Now, since the slope of line 1 multiplied to slope of line 2, it gives us a product of negative 1. Therefore, the pair of lines are perpendicular. So this line is perpendicular to this line. Now let's do some coordinate proof. Let's apply the slope of the line in coordinate proof. We will be tackling more of this on the next lesson. Okay, let's determine if line AB is parallel to CD. So this is AB and this is CD. Okay, let's determine if these are parallels. Okay, line AB has 2 points. We could see that is negative 1, 0, and 4, negative 5, and 4, 5. Let's find the slope of this one. Let's use the formula 5 minus 0 all over 4 minus negative 1. That is 5 all over 5, or 1. Now on the other line CD contains the point of 2, negative 3, and 7, 2. Now let's check the slope of this line. So the slope of line number 2 is equivalent to 2 minus negative 3 all over 7 minus 2. That gives us 5 over 5, and that gives us 1. So since slope of line 1 is equal to slope of line 2, therefore the pair of lines are parallel to each other. Okay. Now let's determine if AB is parallel to BD. BD. Okay. AB to BD. So this one is somehow, let's start with AB. So this is negative 1, 0, and 4, 5. So we already know the answer here. This will gives us negative 1. Now let's check BD if it is parallel to line AB. So we have 4, negative 4, 5, and 7, 2. Okay. Since it gives us a different value, so technically these two lines are not parallel to each other. But let's see if there is another relationship with this. Okay, in this case, if we multiply the slope of line 1, the slope of line 2, it will give us an answer of negative 1. Therefore, the pair of lines are perpendicular to each other. So they are not parallel, they are perpendicular. Okay, thank you everyone. I hope that you learned something and you recall your slope formula. I hope in this revisited lesson you learned that, and we will be able to use that to prove some geometric properties later. So that's all for today, and thank you.